Yeah, I have a question about how we can refactor the existing code base. Let's say in our company, let's say we have 50 million lines of code base.
Yep.
We know things may not be configured in optimal way given the codes are created over the time by many, many people over many, many years. But is there an automated way, or maybe powered by large language model, that can reconfigure the code base
That is
to make
certainly
it 10 times more efficient?
That is certainly one of the huge research questions. Okay, that's not something that right now there's magic that's going to do that for you. Okay, the hardest part of, we have a lot of things can improve things like control flow and so forth. What's harder is when you need to change data representations in order to get efficiency. Okay, because those things tend to be things that end up getting littered throughout the code base. And it's very hard if every, every system that you've got is using the same inefficient code representation. It's pretty hard. What the place that I would say makes the most sense to look at if you are a good-sized company is to look at what your big components are. You can do things with small components, but they tend to be constrained by all the other components around them and doesn't let them do things. But if you can take on things that are large size, you can get substantial gains. There is nothing automatic at this point, okay? It's like, I wish I could tell you, okay, here's my research card and come to me. If so, I would be a very, very wealthy person, I think. And I wouldn't probably be talking here at this particular organization. I'd be talking to all my shareholders,
Thank you for the good talk. I have one question, which is, performance is a great point, but how do you compromise? Do we need to compromise on the reliability of the results? The challenges with LLM is always that, you try to build around LLM with all wrappers, anything, but at the end of the day, I need to build a chatbot that answers in few seconds. I need to improve my performance from the point of view answering a question, right? But at the time, I might compromise on the quality of the results. How do you performance is important, but at the same time, reliability and quality, do we need to work hand in hand together for this?
Yeah, I think this is once again in some sense a trade-off issue, right? Nobody cares about performance for its own sake. Okay, what they care about is what it buys for them. So all these other things, it's a question of if you have better performance, you can, for example, train longer. For example, with the same resources, okay? Or it takes you, you can train more in the same amount of time, for example, with the same resources. Or you can afford to do some more complicated algorithm for learning, okay, which you wouldn't be able to afford to do. It would be much too slow for your application if you didn't have the extra performance. And so the point is to understand, like everybody wants the stuff on this. They want all the human-facing, customer-facing stuff to be done. But as we know, we don't get there without some of the core foundations, things like operating systems. If your operating system is too slow, it's not going to matter, what happens at this level, because it's just going to be too slow, okay? If your algorithm for, your LLM has got, you want to make it be more faithful, that's going to make it more complicated, presumably, and very likely make it slower. So if you can claim back some of that performance because you've invested in the foundational stuff of performance, then you're going to start to be able to address those kinds of things. Okay? So this is not an alternative Okay, performance is not an alternative to, having better, smarter algorithms for LLMs or any kind of generative AI or, classification, whatever you want to talk about. Something that's going to reason better and so forth. It's not an alternative, okay? In some sense, it's the way, one of the things you need to do to get there, okay, is to basically use your resources efficiently. And we're not getting it just from Moore's Law. Sorry. Okay, that boat has sailed.
Okay, great. There's one more question, or? Nope. Okay.
Over
One.
here.
Oh, there's nope. Okay. Oh, yes, there is. Sorry.
I found your talk very inspirational. Thank you, Charles.
Thank you.
I have maybe a naive question. So you frame the software performance engineering as engineering topic. I wonder, why don't you frame it as a science problem? Maybe it can be.
I think when I defined it, I said it was the art and science.
Okay, so it could be optimization.
Because there's a lot of art to
science.
it.
Awesome.
Science. It's also a lot of kind of detective work. Like, why is my thing slow? And among the things that you would like to do from a scientific point of view is you would like better instrumentation than we currently have in our systems. So how do you get pervasive information about performance out of your systems? Many software systems are built, you have no idea where the time is spent, okay, or just very coarse things. And so, we have, one of the things we work on is instrumentation tools. So you can figure out what's going on. And of course, one of the very important things to instrument these days is energy. It's not just speed. You want to say, how much energy is here and what can I do in my software to minimize the energy, especially if you have some form factor constraints, or what have you, or you're doing something sufficiently large that just training once is going to throw all kinds of carbon into the atmosphere.
Thank you. Look forward to explore it as art. Thank you.
And science.
All right, and with that, thank you very much, Charles, Professor Leisterson.
Thank you.